Hi everyone, good evening. Hope you are doing good today. And welcome to the webinar from Orme on leveraging optimization and ethics to reduce cost to serve in a supply chain. The speakers for today will be Dr. Aminkar, who is the founder and CEO at Orme. He's an alumni from IIT Delhi and also a Guinness World Record holder in mental calculation. And me and Syed are alumni from IIM Mumbai, and we are leading the supply chain practice with Orme, and both have 10 plus years of experience. The agenda for today's discussion would be to understand cost to serve and the relevance to business. How do we go about calculating cost to serve and how it helps business in identifying. Followed by a case study. With this, I would like to hand over to Dr. Amit to talk about the committee here.
Good evening, everyone. So we have, in the last 9 years, we worked for 45 plus global clients, doing 110 plus optimization and data science projects, saving them more than $500 million. Our company focuses on operations research and supply chain optimization, GenAI, machine learning, data engineering, and data visualization. So, for our German client, we did a supply chain network optimization, vegetable demand forecasting, and enterprise level tool building, saving them hundreds of millions of dollars. We have a food delivery client in India, one of the giant in India as well as in Saudi Arabia. We were able to save more than $4 million based on figuring out what is the optimal location of the delivery voyage, how the order should be delivered, and then where should the delivery boy stand again. Similarly, for one of the cement giant, we were able to figure out how do we do aggregated production planning along with the supply chain network optimization, saving them more than $6 million. So, in many of these projects, cost to serve is a very, very important part. Actual cost to serve or a probabilistic cost to serve. So when you think about a food delivery, initial location of the food delivery voyage, that also depend on, that impacts what would be your cost to serve. Same way where you're looking at a supply chain network optimization. For your European customer, when you're thinking about maybe getting supplies from Poland versus China. So Poland might be, manufacturing cost could be higher, but you have a lower logistics cost as well as ability to get faster in the Europe. But in the case of China, you might not have that same benefit. But it also depends on how far do you need and what cost it's costing you. Only you look at your logistics cost, manufacturing cost. That's why total cost to serve play a very important role. Same way, when it comes into in the cement industry, if you look at demand of Madhya Pradesh in India being supplied, let's say, from Orissa, another state, you would have to look at the state combination. When you look at your logistics cost, you look at the manufacturing cost, what the GST, different tax implication of the different states are when you figure out the total plan.
So can we just put down the slides? So it's not coming out for this. The display setting here. Thanks, Dr. Amit, for taking us through the case study. And now we come back to how does cost to serve help a business. So assume you are a FMCG company with you have products like chocolate, coffee, and milk products, and you are serving to the various customer segments like general trade, the normal kirana stores, or the organized trade in terms of the DMarts of the world, and also to the e-commerce like Amazon and Flipkart. You would like to understand of serving each of these products to each of these customer segments. And when you do a detailed analysis, you will realize that at least 10% of the products we are selling at loss, and at least 10% of the customer segment, we might be not that much profitable. So, as an organization, you will have those questions that are my processes cost efficient? What are my operational cost or the manufacturing or the overall cost? And as a business owner, and how are your suppliers doing, are there any possible opportunities of reducing the overall cost of running your business and you would like to understand the, indirect cost, or, which customers, you want to target, etc. So irrespective of the organization's focus area, this topic is going to be relevant for you. So cost to serve is a metric which talks about the total cost of running the business, which includes all the direct costs, which is basically the variable cost per unit, and also the indirect cost, which is like fixed cost of running fixed cost in business, like it might be, admin related cost or the warehousing cost or your technology related cost. So in a cost to serve analysis, you try to, identify those hidden spots in the, value chain, and that will improve the profitability. So a cost to serve analysis will help you enable better customer segmentation, define the pricing strategy, also help you achieve a better efficiency or the operational efficiency with, while enhancing the customer value. So how do we go about calculating the cost to serve? You define the overall business objective in terms of which area of the, understand at a product level or the customer level or the geography level. You break down your cost, identify the various costs in the supply chain in terms of what is the production, manufacturing cost, transportation cost. You allocate all of these costs. So for example, fixed warehousing cost will be dependent on the volume of the product, because usually the warehousing is based on the volume. Thereby you go about calculate the total cost to serve. And with this analysis, you will identify the high cost customers or the products. And accordingly, you will define your business strategy in terms of the pricing, segmentation, or, optimization of the processes. If you see on the right hand side, the graph against the number of realize that with the increase in the number of facilities, the inbound transportation cost is increasing, whereas the outbound transportation cost decreases and the inventory cost increases. And the overall cost curve, if you see between the dotted lines, you will see an optimum point where the wherein the most optimal point in terms of the total cost is achieved. And move to next. And if you want to add anything, so you can. So coming back to the last case study in which I have different product categories like coffee, chocolate, or the milk products. In a cost to serve analysis, you would be able to analyze what is my cost to serve of coffee or any of the product categories, and for different customer segments. So I can break down by product, by customer category, by a combination of two, by the operations in terms of the procurement, manufacturing. You can analyze also by the cost in terms of fixed versus variable, and also by the product flow in terms of what are the costs across the flow path in terms of movement of goods from the supplier to the manufacturing in terms of the production cost, then from production to the distribution centers to the customers. What's the cost along the product flow path? So that can be sliced across various segments and detailed out. And then how do we go about modeling the cost to serve? We in a typical cost to serve analysis or an optimization exercise, we go about first of all identifying or defining my baseline network, and any of the technology or tools can be used. For example, AIMS, SC Navigator, or LlamaSoft, or you can do Excel based modeling or Python based modeling, and you go about defining your products. You go about defining the demand periods, total demand across products, your sourcing policies, cost across the network in terms of the fixed warehousing cost or the cost of managing a site or the production cost, and the defining the overall throughput and the current cost, which gives you the practically the as-is network. Then you identify the opportunities. You run an optimizer and identify the opportunities in the as-is network. Then you create scenarios, various what if scenarios to analyze the cost to serve and the opportunity to define your business strategy. You will see various what if scenarios, and basis that you will define the strategy. With this, I would like to hand over to Sayyad to take it over and also cover the case study.
Sure. Thanks a lot, Raman. Welcome, everyone. Very warm good evening. So over here, if we see, we are looking at a framework that can be used for identifying or understanding the total cost that a network has incurred. And we can understand how we can slice and dice that network. So, for example, if we see over here, you go about first collection of the data, then you want to understand what is the current cost. So, like leveraging the data that you have collected in the first step, you try and understand what's the total cost and production and demand and throughput, for example. And having collected that, you kind of slice and dice that data to understand how is it looking like for a specific geography. How is it looking like for a specific customer? How is it looking like for a specific product, for example? And those calculations, they are called as baseline. Basically, it's all about identifying the existing situation, existing costs. And once you do that, it kind of gives you an insight about how my network is laid out, what are the costs associated with it. And after doing that, you try and optimize it. So, for example, suppose there is a customer X and we are currently supplying to that customer X from warehouse A. Imagine that if warehouse B would have been used instead of A, it would have helped the customer better in the sense that the total transportation cost might have got reduced. I mean, it can be such a situation. So this change from warehouse A to warehouse B is called optimization. So, and this can happen in multiple permutations and combinations, obviously. So identifying that new flows with the same nodes, instead of customer warehouse A, warehouse B, things like that, that is nothing but optimizing the baseline situation. And once you do that, another way of looking at your total network is changing the existing capacity of the warehouses. Say, for example, some warehouses, I just increase their capacity because they are running at full, and more products are now flowing through it in the model. And that in turn will calculate the total cost that it has incurred. And in many cases, that total cost also gets reduced. So basically, optimizing the existing scenario and unconstraining the optimized scenario. These two situations are nothing but identifying opportunity in your total cost to serve. So this is how network analysis is connected with cost to serve. That is the total cost that a company experiences for serving a particular customer or a product. Moving forward, we created a mock data for you in which we have created a healthcare distribution company. So imagine a company that is into distribution of healthcare products, and it has got, say, 5 suppliers across multiple countries. It has got 9 warehouses, and it has demand from, say, 60 customers, which are spread in 3 different countries. And this particular healthcare firm, imagine, has got these 4 products, and these 4 products are divided into some kind of SKUs. That is, say, bigger pill, smaller pill, tablet 1, tablet 2, things like that. So now the situation over here is that the product which is being purchased from the supplier at a specific cost is being sent to the warehouses in bulk, and from the warehouses it is going to the customers. And these steps will involve some costs. For example, when the supplier is giving its products to the health distribution firm, it will charge some price, right? So that is their first cost, the fixed supplier cost or the variable supplier cost. Then warehouses, this movement from the supplier to the warehouse, this is called primary transportation. And this would for sure incur some transportation costs. And at the warehouses, products would be handled, moved around, packed, unpacked, etc. That is called as warehouse handling costs. And once that is done, the products are moved from the warehouses to the demand locations to these 60 customers. and that is called as secondary transportation. So any network will have fixed and variable supplier cost, primary transportation, warehouse handling cost, and secondary transportation. These costs, once you calculate and identify, you can create a network. And this network we have created for you already so as to understand and review the overall what is meant by cost to serve. So for doing that, we have leveraged one of our partners tool called as AIMS. So this SC Navigator or AIMS is one tool that can help you understand the total network cost and also help you understand breakdown of the cost for each segment, for each customer, for each product, so on and so forth. So if you see over here, for example, what we have drawn in here are, say, let us first look at only the suppliers. So these red triangles are the suppliers spread across multiple countries, and they are going to supply product to these warehouses. Okay, these warehouses are the warehouses of our healthcare firm that we have identified. And from these warehouses, the products move to the end customers. So if you see over here, warehouse and customers, this is how the products are going to move from each warehouse to the end customer, and the supplier to the warehouses. So the blue lines are the primary transportation, the gray lines are secondary transportation, the red triangles are suppliers, the light green rhombuses are the warehouses, and the circles are the customers. So we modeled this for you already, and we have ran the optimized scenario as well as baseline scenario as well as unconstrained optimized scenario for you using and the tool has got really neat interface for you to do that. So I can quickly take you through that before going into understanding. So if you see over here, I'm running the scenarios, the models with an objective of maximizing the profit, right? And in the optimized baseline, I have not enforced any restriction. Whereas in the baseline, I have restricted and enforced the existing constraints, right? And in the relaxed optimized scenario, what I have done is I have relaxed the maximum warehouse capacity. This is what we spoke when we were discussing the slide, right? You have three situations and scenarios. One is the baseline, that is what is existing, as is what's happening. Second is optimized, in which I am allowing the tool to identify a better flow. So same nodes, better flows. The third one is nodes, either nodes are changed or the capacity of the nodes is increased. So that is what I did over here for you. And all the three models have been run. Let us go and review the results. So if we see over here, we can check the KPIs. So having run those three scenarios, we can quickly see, the baseline scenario that we have run. If you remember, we spoke about the supplier variable cost. Then we discussed about the transportation cost, primary, that is moving from the supplier to the warehouse. Secondary, that is moving from the warehouse to the end customer. Then warehouse handling cost or warehouse variable cost. So if you pick up any supplier or a warehouse, you are going to incur some fixed costs associated with it that have been incorporated, modeled over here. And if there is any movement between the warehouses, that's the inter-resource transportation that's happening, for example. and then whatever physical revenue we are generating from the customer. So like if you see over here, all these things that are there, the sum total of this is your cost to serve. So you can break up the total cost to serve or a stage, and you can compare that against the revenue you are generating, and the difference between this revenue and all. So in this model, the mock model that we have created for you, you can see that in the baseline, that is as is the existing situation, the company is making approximately $9.5 million, right? And if I optimize it, it is going to make better profits of approximately $11.5 million. So basically, what we are doing over here is allowing the tool to run the optimization, ensure that the number of flows that are happening, they are happening in the best possible manner from the nearest warehouse to the customer instead of farthest warehouse, so as to ensure reduction in the transportation cost. So if you compare over here, you see the secondary transportation is the major significant difference, right? So once that is done, we again ran it with a relaxed optimized baseline. Basically, as I showed in the previous screen, that I allowed relaxation of the warehouse total capacity. So if you see over here, there is a slight improvement of the total profit. It is 11.533 millions, whereas it is 11.531 million. So that is how we ran it. Now coming to total cost to serve in these three situations. So if you see over here, again, quickly show you. This particular table. This can be of interest for us. So what the tool did for you is that it identified a bunch of customers, the products that are there over here. So like for a given customer and a product, what is the total optimized profit that the company is generating for these three situations? The baseline, which is the existing situation, optimized baseline, that is in which the tool has identified a better way of moving it around, and relaxed optimized, where you unlocked the warehouses, right? So if you want to see, for example, what are my worst performing products, or what are my worst performing customer and product combinations, right? So I simply say, want to check that, I filter it or sort it from lowest to highest. So if you see over here, for customer 21 and val 3, we are making a loss of approximately $13 per unit. So if you see, cost or revenue breakdown per unit is provided here. And we are seeing that the total cost to serve this particular product is negative 12.87. So though at the aggregated level, we are seeing that we are making a profit of approximately 9 million or 11 million based on the situation and scenario, right? But if you see over here, for this particular product, we are incurring heavy costs. Reason can be, it can be the high transportation, it can be, say, low price at which we have kept that product, or it can be, say, high price at which we are buying it from our supplier. So if you see over here, you can see sorry, it's taking time, but yeah, if you see over here, you can see that there are multiple costs that are associated. For example, the revenue per unit, that is basically the price at which we are purchasing it from them. Okay. Sorry, the customer got filtered. Okay, so I can, say go about and select a particular customer if I want to. I can go about and select a particular product if I want to. So for example, I'll take you quickly through this. Right. So if I want to specifically choose how is the situation for vials, I just go and select vial. Vial 1 and 2, for example. And it's giving me how's the total cost to serve for vials for all the customers. And I can review how much profit am I making. So what we wanted to drive the point over here is that, for this situation in which we have modeled, right, we can understand and review and analyze what's the total cost that a particular company is incurring, and then divide that cost in terms of suppliers, in terms of countries, in terms of geographies, in terms of products, to understand how that cost would impact me. And for example, we saw that certain products are loss making for us, right? Though we are making profit overall, but those are loss making for me. And what I would try and do is that either increase the price of those products or exit from those products, or ask the supplier to supply those products to me at a cheaper cost. So this is the same screenshots that we showed you over there are being repeated over here. So for example, here you can see what is the total revenue and then the total cost. And this line is nothing but profit, the difference between them. Again, these are screenshots from the same tool that I was showing you. And if you remember, this was one slide which Raman showed. And in that, we spoke that the cost to serve can be studied in multiple ways by the stage of the supply chain, primary transportation, secondary transportation, warehouse movement. We have seen that happening in the model while running the model, right? It can also be studied by, say, raw cost, indirect cost, so on and so forth. Again, by, say, warehousing, by logistics, etc. But if you see over here, these two were the ones that we focused on during our discussion by customer category, and by product. So which customer is for which product is costing me more or costing me less. Yeah, so this is what we wanted to present in terms of a case study, how, the total cost that a company incurs can be looked at, can be sliced, can be studied, and how can opportunity identified in that cost. I hope you liked this. Next 5-10 minutes we can spend on discussing the questions if we have any. And yeah.
Anyone? You can put it on the chat if you have any questions.
Do we have any questions?
I don't think we have any.
We can give 2 minutes before, stopping the call. But yeah, I hope you guys like the conversation. Would be happy to connect and engage if there are any questions offline. You do have my email ID, or we can connect on some social media as well as LinkedIn. Yeah, sure. Thanks a lot, everyone. Thank you.
Thanks everyone for this.
Great presenting this particular thought to you. And thanks, we'll connect again. Thank you. Bye.